This video is going to talk about electric current and how to make a simple circuit. So we're going to start with the foundation to DC electricity. And DC stands for direct current. So we don't do any AC current here. Now the definition of current is how much charge flows through a wire per second, per unit time. So the units for it is amperes, which is basically coulombs per second. Okay. Now I'm going to go right to circuit. Now the bare minimum that we need to have a circuit, we need a source of energy. Okay, so we're going to be using a battery in this class. So the symbol for a battery is a long line and a short line next to each other with a gap in between. Now the long line is the plus and the short line is the minus. Conventional current flows from plus to minus. It goes around the loop, but it originates at the plus and it goes around and it comes back to the minus and it just continues in that loop. It goes through the battery and it continues. This, what you see here, these lines here are basically just wires. Okay, so in order for the electricity to flow, you have to give it a path for the current to follow, right? And I'm going to do an analogy with water probably. Okay. So this is another wire. We do everything at right angles. Okay, and then you have to have something that will use up this energy. Okay, so we put a resistor there. That's the symbol for a resistor. Okay, this is a battery. Batteries provides a voltage or basically energy. This resistor could be anything. It could be a light bulb, it could be a doorbell, it could be a microwave, it could be pretty much anything you want it to be. So it's basically something that's going to use up the energy. And then a switch is not necessary, but I think it's convenient. This way you can decide when to turn on this resistor and when to turn it off. Okay, so the symbol for the switch, if it's like in this position, it's open. Okay, if it's in this red position, it's closed. So if it's in the black position, it doesn't allow, the circuit is broken and current cannot flow. So the current goes in this direction, just like I showed you earlier. So all right, maybe in class we'll talk about the water analogy. Now let's talk about resistance. Okay. Resistance is basically the load that's going to use up the energy or the energy provided by the battery. The units for resistance is ohm, and this kind of like this omega, this uppercase omega, it's like a horseshoe kind of. Okay, so that's the units, and that's to honor Greg Ohm or George Ohm, I think. What was one or the other? Okay. Now to find the resistance in a wire, this is just in a wire. Okay. The formula is, this is rho. Okay, this is the resistivity of the material. So every material has a different value for resistivity. This is the length of the wire, and this is the cross section area. So we're going to think of the wire as a kind of like a disc that has an area of A. So the area of that is basically pi times the radius square, and all the times this R here is usually expressed in millimeters, and you have to change it to meters. So you can see that resistance is proportional to the length of the wire, and it's inversely proportional to the radius square. So it follows that inverse square law. And here in this list here, you have different resistivities of different materials, and they are all, so the way you read this is 1.59 times 10 to the negative 8. Now the units are ohms times meters, and here's why. R is rho L over area. So if you want to find the unit for rho, you have to isolate it. So resistance is in ohms, area is in square meters, and L is in meters. So you can get rid of meter, and you're left with ohms times meters. And that's really all I have to say about this video. So it's extremely short, just to introduce DC circuits. All right, see you tomorrow.